Here's our third and final part to Solving Systems by Substitution little video series. Now, as you noticed, in part 1, that was probably the simplest system that we would get. Part 2 got a little bit harder because it didn't look exactly the way. Part 3, this system is going to be harder than the previous. So we're actually building as we go through. Now, go ahead and take a look at this system that I have up here. And while you do that, I'm going to label. I have equation 1 and equation 2. Now, if you think about it, what is different about this system compared to the previous systems we have? Well, hopefully you can look at this and notice that first, neither system is in slope-intercept form. Neither system has been solved for either x or y, and both systems are in standard form. So, this is our first time compared to part 1 and part 2, where we have to actually do step 1 of solving a system by substitution. Remember, step 1 is to solve one of the equations for a variable. So we have to actually do that this time before we can substitute. In part 1 and part 2, we didn't have to because they already had one or both equations solved for either x or y, so we could go right into the substitution. So now the question comes in, which one, equation 1 or equation 2, do we want to solve for? Well, we generally want to solve for the variable, either x or y, that has a coefficient of 1. Well, if you look at it, in equation 1, y has a coefficient of 1. And in equation 2, both x and y have a coefficient of 1. Well, so we have some flexibility here. I'm actually going to go with equation 2 because it has all coefficients of 1, and it's a little bit nicer if we go ahead and solve, and it'll have a lot less coefficients other than 1, whereas this one is a little bit harder, but really it doesn't make a difference. So in equation 2, I'm actually going to solve for x because I want to illustrate the distributive property. Generally, you could have solved for y, but I'm going to go ahead and solve for x. So here's how we do that. First, you write the equation. So here's equation 2. Now, if I'm going to solve for x, that means I need to move everything else away from it. So to move this y, since it's being added, I'm going to use my inverse operations. So instead of adding, I'm going to subtract y. So we're going to get x equal to, and this is an expression, we cannot combine like terms, so this is negative 7 minus y. Here is my new equation number 2 that I'm going to substitute in. Notice I labeled it as well because I want to keep track of my work. So what's going to happen now, since I solved for x, this expression right here is what I'm going to solve back into equation 1. You never solve this into your original equation. Like, for example, what I'm telling you is I'm not going to put this back into here because I just manipulated. If I do that, I'm just going to end up with 0 equal to 0. Everything cancels out. So what I'm going to do is take this, since it's equation 2, that means I need to substitute it back into equation 1. And since I solved for x, this is going right here. So I'm going to draw my little arrow to show you. This is going to go right into there. So let's go ahead and substitute. So what happens? We're going to get 2. Well, let me rewrite it first. Here is my equation number 1. I'm going to substitute this in for x. So when I do that, here's what I get. 2 times the quantity, because it's multiplication, of negative 7 minus y plus y equal to negative 4. So I'm going to use distributive property. 2 times negative 7 is negative 14. 2 times a negative y is negative 2y. And then we have plus y equal to negative 4. We can combine like terms right here. So we get negative 14. A negative 2y plus 1y is a negative 1y equal to negative 4. I'm now going to add 14 to both sides. Again, inverse operations. I'm left with, now be careful, this is subtracting y. That still means y is negative. This negative 14 plus, negative 4 plus a positive 14 is positive 10. Divide by negative 1 because y needs to be positive. Y equals negative 10. And just like before, once we get our y value, we need to substitute it back into either equation to find our x. Now the key is, when we go to substitute our first value back in, we are going to use one of the original equations from the book. Do not substitute it back in to your new equation, because here's why. Let's say you go to solve for one of your equations, but you solved wrong. If you go to put your value back in, you're now testing it into an equation that could be wrong, so you'll never know if it really was correct. So you want to test it back into the original equation the book gave you. So let's go ahead and use equation 2, since it has coefficients of 1, so it's simpler. So now I'm going to substitute my y value into equation 2. So I'm going to write it here, x plus y equals -7. So when I substitute -10 in, I get x minus 10 equal to -7. My inverse operation is to add. So x equals +3. So let's test our answer. Here's the first one. So I said x was +3 and y was -10. Well, 2 times 3 is 6, and 6 plus -10 is in fact -4. Good. So let's test our second one real quick here. X is 3, y again is -10. 3 plus a -10 is a -7. So our final answer is 3, -10.